herky-jerky because I'm not planning this in any way. This is just kind of an experiment for how much, what size of file I'm going to have, and for those of you who want to access material outside of class, obviously I want to post it for you. But this is very experimental. The ones I record at home will be more structured. It'll just be me in a room. I'll have like bullet points and we'll go through specific things. But this is going to be very kind of all over the place. So when you watch it, it's going to be kind of a lot of pauses. Maybe I'm asking a question and the microphone is not picking up the voice of the student. So just kind of bear with me. Okay? So today we're going to talk about organic chemistry. Oops. Already, first blooper. Turn the pen on. Okay. Now, organic chemistry, very simply, is the chemistry of carbon. That is obviously a very general, very non-specific definition, but for us it works. We're going to be studying compounds that contain mostly carbon. If you've ever heard the phrase, a carbon backbone, that's what we're talking about here, are chemicals that have mostly carbons. The chemicals in your body, for example, you've studied biomolecules, proteins, carbohydrates, nucleic acids, lipids. They all have a carbon backbone. They're primarily made of carbon. And remember, the part of carbon that gives it that ability is the 4 valence electrons and the number of bonds it can form. It can form 4 single, 2 double. There's many combinations, so it makes it a good building block. Okay? So the first thing we need to understand in the world of organic chemistry is that there are different chemical groups that can be attached or part of this carbon backbone. And that is, those chemical groups are what give it the reactivity, what give it, what determine the rules for naming, things like solubility in water, all from chemical groups. So I'm going to go through, I'm going to make a list here, and I want you to memorize this list. So first of all, when you have carbons singly bonded to carbons, that is a chemical group called an alkane. The naming system we're going to study includes the chemical group as a part of the name. So it's important we understand how to indicate what chemical group is present with the name. And that chemical group is indicated with a suffix. Remember, a prefix is what begins a word. A suffix is what ends the word. So in this case, the suffix for chemicals that are alkanes is ane. They will end with ane. Examples: methane, ethane, propane, butane. Those are compounds that have singly bonded carbons and nothing else. Okay? We have doubly bonded carbons. Those are called alkenes. Suffix ene. We have triply bonded carbons. Those are called alkynes. Yne is the suffix. And by the way, this will all be found in chapter 25, where you've been assigned reading. I know you're going to want to put it off, so this is now recorded for posterity's sake. We're going to upload it to YouTube, so it's going to be eternal now. Me making this statement. I know you're not going to want to study. I know you're going to put it off until the last minute, and eventually it's going to come May 27th, and there's no more time to put it off. So please don't wait until May 26th to start reading this material for those of you who are going to put it off. Just my 2 cents. Okay, back to the regularly scheduled broadcast. We have chemicals that include... Now, let me give you a little word here. When I write that R, I don't really know if it has a name. I've always said, and I've always thought of it as the rest of the molecule. So when you see an R, that basically is saying the rest of the molecule is just generic carbons. Think of the R as alkane groups, C's bonded to C's. Okay? And so the only thing they want you to focus on here is this thing bonded to the R. It's an OH group. That's an alcohol. The suffix for alcohols is -ol. Methanol, ethanol, propanol. Okay, you've heard of probably all of those. We did a lab on those. Pentanol. All kinds of these things. Let's see. What else do you got? You need to know what an aldehyde is. So this portion right here indicates an aldehyde. It's another name of a group. Aldehydes are very fruity, very smelly, as are esters, which we'll get to later. These end in the suffix -al. Methanal, ethanal, propanal. Alcohols are methanol, ethanol, and so on. You need to know ketones, which look like this. The dash you're seeing to the right here is read as prime, R prime, which simply means it's a different R than this one. They could be the same chemical group, but they're not necessarily the same. Again, generic. The thing to focus on is this part. That chemical group surrounded by carbon groups on the outsides is known as a ketone. That's all it's saying. The R is just a generic placeholder for other chemicals. Okay? Ketones end with the suffix -one. Methanol, well, there would be no methanol. Propanone, butanone, pentanone, and so on. We have carboxylic acids. Let me create some more space here. Carboxylic acids have the following chemical group. This portion here is the acid portion. Carboxylic acid. This is generic. So let me write that down. The suffix on these is oic acid, methanoic, ethanoic, propanoic, butanoic acids. Kyle.
We're going to have to memorize these?
Memorize what?
Like all the formulas and names?
You have to memorize how to identify the chemical group. So you have to memorize the portion that is the unique portion here. These portions are not labeled R. The naming system, you're going to have to learn the naming system. I wouldn't call it memorizing. Because what we're going to learn is all we have to do is count the number of carbons and recognize the group. So with 4 carbons and an OH group, but means 4, anol. Really simple. So in a way, yeah, memorize, but not quite memorize. Does that answer your question?
Yeah.
Okay. Carboxylic acid and the last one are halides, where X is one of the halides, that's halogens, or iodine. Sorry, I can't squeeze the word halide. There it is. These don't necessarily have a suffix, so for these we use the prefix, excuse me, I'm having trouble here, of fluoro, chloro, bromo, or iodo, one of my personal favorites. Okay, now that's a lot of information. So let's just practice. I mean, this is very simple. One of the things you are asked to do in the IB system is name organic compounds. And when you name organic compounds, there's 2 things that are very important. Okay, so let me create a little space here. So when you're naming compounds, 2 important things. First, you must find the longest carbon chain. Second, name using functional group. Now, I will admit freely, this is not by any means a detailed series of instructions for naming. Very generic, but when I provide you with these examples, it's going to be very, very simple. I'll demonstrate to you. So let's just do it. We're just going to do example after example after example, and then we're done. That's all we're doing. We'll just do maybe 10 examples. I'm done for the day. You'll be able to study for the rest of the period. Okay? So here's how it works. You're going to be given. You are responsible, by the way, if you read that curriculum, you are responsible for naming organic compounds containing those functional groups up to 6 carbons long. So we're going to practice in that range. So let's take, for example, this. Now, a few words about the symbolism here. Carbons must obey the octet rule. So notice, none of those have an octet by our rules of Lewis structures. So you have to understand, when I show this, I'm indicating that each of those carbons has an octet. So imagine these dashes that I'm drawing on the outside have a hydrogen atom all around the outside. So sometimes I'll draw it in this form. Sometimes when we get good at this, I'll just draw the carbon backbone. It's implied that they are saturated, or covered, I shouldn't have said saturated, that they are surrounded by hydrogen atoms. Okay? We just leave the hydrogens off to save time. Okay. Now go through your notes. What chemical group is present here? This is an alkane. The ending will be ANE. What's the longest number of carbons in a chain, in a row? 4. So we have to understand how to combine those two things. So the number of carbon issue is very simple. You only need to know up to 6. So when there's 1 carbon, we use the prefix meth. When there's 2 carbons, we use the prefix eth. When there are 3 carbons, we use the prefix pro. 4, but, not but. 5 is pent. And 6, hex. So, this is a 4-carbon chain. The chemical group is alkane, so it ends in ANE. This is butane. Very simple. If I had 3 carbons, what would it be? Propane. 2 carbons, ethane. 5 carbons, pentane. 6, hexane. See how simple it is? It's extremely easy. Now, alkanes are obviously the simplest. So let's get a little more. Yeah, Nick.
You know how you said that's propane?
Yes, sir.
You just kind of have to, know that you have to throw in the P. You just kind of have to know these things.
Throw in the P.
PRO and then ANE. So technically it'd be proane.
Yeah. There are some things you know over time, like experiential things, because technically I'm leaving off a lot of detail. And technically what this is a, I'll tell you now, it'll be on the video so you can rewind it many times and go back and see it again. The alkane group is honestly indicated with carbons singly bonded to each other, but surrounded by singly bonded H's. So I guess the easiest way for me to say it is that so there could be many more carbons in this area over here. So propane is this one, saturated, surrounded by H's. So I've boxed in this section here, it's this section here, right? It's propane without that H. That's called a propyl group. It's a chemical group called propyl, P-R-O-P. YL. So what we're doing is we're cutting off the YL ending and we're putting in the ANE for an alkane. That's kind of what we're doing. But that's just an overly complicated, we don't need to know that. So experience will tell you. Good news, it's multiple choice. So they're going to do that for you. So you don't have to worry about that too much. Okay? And they're not going to penalize you for putting proane instead of propane. I really doubt they will. Okay? Good? It's a good question. Okay, so let's do some more. Do a couple more and then we'll stop. Okay, so let's talk about this one. What do you